Example 7. Discuss the curve f of x equals to x to the 4 minus 4x cubed with respect to concavity, points of inflection, and local maxima and minima. Use this information to sketch the curve. Okay, so our first step is to, do you remember what is the first step? Okay, yes, the first step is to figure out the derivative. Okay. So the derivative of x to the 4 is 4x cubed. Derivative of 4x cubed is 4 times 3, which is 12x squared. Okay, so in the previous examples, we either find interval of increasing or decreasing, or we want to find interval of concave up or concave down. But in this problem, because we need to sketch the curve, so we actually need to find all the information, increasing, decreasing, and concavity. Okay, all right, so that's why we need to factor the derivative completely and find the critical point. What is the common factor? 4x squared. And then what's left? We have x. Here we have 3. Okay, we set it equal to 0. So if it's polynomial, we set it equal to 0. If we have a quotient, we set the numerator is 0 and the denominator is 0. Because critical points, remember critical points, they are in the domain. And then either f prime is 0 or f prime does not exist at that point. Okay, so here we have x is 0 and x equals to 3. So these are the critical points, okay? So the second step, we need to take the second derivative. When we take the second derivative, we use this formula. We don't use the factor one because you don't want to use product rule, right? So the derivative of 4x cubed is 12x squared. And the derivative of 12x squared is 24x. So you can see on the common factor is 12x. And what's left? We have x minus 2. Okay, so we set it equal to 0. We get here x is 0, and here we get x equals to 2. Okay, so that is possible inflection points, but they're not, we don't know whether it's inflection points yet because we haven't checked the second derivative change signs. Alright, so the next steps we have, we find a domain. Our domain is minus infinity to infinity. Okay, so we're gonna draw the table or diagram. Okay, so we draw the real number line because our domain is all real numbers, and then you wanna plot the important points. So the important points are the critical points and the possible inflection points. So they are 0, 2, and 3. Okay, so here we have minus infinity to 0, 0 to 2, 2 to 3, and 3 to infinity. Okay, so we have 3 important points, and that divide our domain into 4 subintervals. Okay, so here we're going to have a big table because instead of just looking at f prime and f or f prime prime and f, we actually look at 3 of them: f prime, f prime prime, and f. Okay, so for f prime, we want to fill with so we want to fill with, is it positive or negative? Okay, and let's see. We know the critical points are 0 and 3. So 0, so that's why at 0, f prime of 0 is 0. At 3, f prime of 3 is also 0. Okay? And then on each interval, we pick a number in the interval and plug in our f prime. So the first interval, what number is in this interval? -1, yes. So we plug in -1 into where? Do we plug in this guy or this guy? We plug in the factored form. Okay, so when we plug in -1, 4 is positive, -1 squared is positive, -1 minus 3 is -4, -4 is negative. So the answer is negative. Okay, and then actually, you see here, they're actually with the same sign. So which means you only need to pick one of the number in these 3 pieces. So we can pick the 2. Why is that? We look at the f prime. F prime, the critical points are like 0 and 3. So when you pass through the critical points, f prime will change signs, but here this whole region is actually considered as one piece. Okay, so that's why they will have the same sign. So when we plug in 2, 4x squared is always positive. 2 minus 3 is what? Is also negative. So that's why we have negative here, negative here, negative here. And then for this interval, we can choose the 4. Right? So we plug 4 in, 4x squared is always positive, and 4 minus 3 is 1, so that is positive. How about the second derivative? The second derivative, we have the critical, not critical points, possible inflection points are 0 and 2. So that's why at 0, f prime prime is 0. At 2, f prime prime is also 0. Okay, so you can see it separated the domain into 3 pieces. Okay, so let's figure out the sign on those 3 subintervals. Okay, from 0 to so from -infinity to 0, we can pick -1, and then we plug in the factored form of f prime prime. So 12, and then -1 is negative, -1 minus 2 is -3 is also negative. 2 negative give us what? Positive. And then here we can pick 1. Okay, so 1 is positive, 1 minus 2 is -1, that's negative. Okay, so here actually they will have the same sign in the f prime prime because they are considered as like one piece. Okay, so you just need to pick like the 3 and plug in 12 times 3 positive, 3 minus 2 positive. So we have positive here, then we must have positive here as well. All right. Oh yeah, so f prime prime we want to answer like positive, negative, or question mark. Oh, sorry. Positive or negative. Yeah. Okay, for f, what do we want to answer? Okay, so before, if we care about increasing and decreasing, we can answer like up or down, right? When we care about concave up or down, we can do this. But right now, we want to combine all this information. So what we do is, you imagine we have a circle, okay? And we divide it into 4 pieces. So we have this guy, this guy, this guy, and this guy. So it's like a circle, and then you divide it into 4 pieces. Okay, so let's look at this guy. The left upper, okay, the upper left one, we have increasing or decreasing? We have increasing, and it's concave up or down? It's concave down. And then the right upper one, we have decreasing and concave down. The left lower one, we have decreasing and concave up. And then the right lower corner, we have increasing and concave up. So let's look at the first piece. Let's look at this piece. F prime is negative, so F is decreasing. F double prime is positive, so we have concave up. Then which piece? Decreasing and concave up, we have this shape. So actually this is the actual shape of that pieces on the graph of the function. Okay? And then from 0 to 2, F prime negative, so decreasing. F double prime negative, concave down. So decreasing and concave down is like the right upper corner. So the shape is like that. Okay? And then next, on the interval from 2 to 3, we have decreasing and concave up. So we have like this. Okay, and the last one from the interval 3 to infinity, we have increasing and concave up. So we have this. Okay, all right, so let's imagine. Okay, this guy, we have decreasing and then like that. So what's this point? Well, it's not maximum, not minimum, but it's inflection point. So this is inflection point. Okay. Here we have decreasing and then also decreasing. So you can see this is neither maximum or minimum, but it's an inflection point. And this one, we have this piece and then this piece. So what do you say? This is a local minimum. Okay, this is the third step. We find the domain and then we draw the combined diagram. Okay, then the next step. Oh, I should write smaller. Okay, the next step is. Okay, so the next step. We want to plot the important points. So what are the important points? They are like a 0 and a 2 and a 3. Let's plot this into our f. Okay, so what is f? X to the fourth minus 4x cubed. So the first one when we plug in 0 is 0, right? And then when we plug in 2, x to the fourth, so 2 to the fourth minus 4 times x cubed, so 2 cubed, we get 16 minus 4 times 8 is 32. We get negative 16, right? And then the next one, 3 to the fourth minus 4, 3 cubed. Can you see there's a common factor of 3 cubed? And then you get 3 minus 4. Oh, that is minus 1. So, and then it's minus 3 cubed. 3 cubed is 27. Okay, so we plot the important points. And then, step 5, we're ready to draw the graph. Okay, so let's see. We have the x-axis. And we have the y-axis, okay? And then why do I have this shape? Because I know a lot of important points are positive. So we have 0, 2, and 3. And then a lot of important, so at 0, it is 0, okay? At 2 is minus 16. So let's say this is minus 16. And at 3, we have minus 27. So minus 27, okay? So we plot the points first, and then on each piece, we remember this actual shape. We're gonna copy that piece to our graph. So the shape, so start with the point. The shape looks like that. Okay, so copy that down. And here, well, what was the shape? We're gonna connect those 2 points. But the shape between 0 and 2 is like that. Okay, so you have to show the shape. Don't draw the line segments, because the line segments I'm not able to see whether it's concave up or concave down. Okay, so make sure you draw the shape. It's either like a bowl or like an umbrella. Okay, and on the interval from 2 to 3, the shape is like this one. Okay, so we have go down. Okay, and then after 3, we have go up. Okay, so that is this is the graph of the function. Okay. Example 8. Discuss the curve. Same thing with respect to concavity, points of inflection, local maxima, minima, and sketch the curve. Okay, please pause the video here and try to work on this problem first. Okay, you done? All right, let's follow the steps. First step, we want to figure out the derivative. Derivative of 3x to the 4th is 12x cubed. 2 times 6 is 12x. Okay, and what is the common factor? 12x. What's left? X squared minus 1. So that's 12x, and we factor that completely, so that is x plus 1, x minus 1. Okay, it's polynomial, so we set it equal to 0. If it's like a quotient, you also need to set the numerator 0 and the denominator 0, okay, to find the critical points. And here we get the roots are x is 0, x is minus 1, x equals 1, okay? So, and the second step, what is the second step? Do you still remember? All right, f prime prime, yes. When we take the second derivative, do we take the derivative of this guy or this guy? This one, right? Because we like power rule instead of product rule. You don't want to do product rule because you still need to multiply it out. So derivative of 12x cubed is 36x squared. Derivative of 12x is 12. And then we factor out 12. We get 3x squared minus 1. Okay? How do you factor this guy? Keep in mind that a plus b, a minus b is a squared minus b squared. Okay, but here you can think about 3 is like square root of 3 squared. So that's why here we have 12. My a is now square root of 3x plus 1 and square root of 3x minus 1. Okay, and you want to set it equal to 0. Okay, so you might have questions like, what if I don't know how to factor it? It's okay. You can set this guy equal to 0, and then you get 3x squared minus 1 is 0. 3x squared is 1. X squared is 1/3. X is plus or minus 1 over with 3. Okay, so you get the same thing. Okay, where you factor it completely, here you still get negative 1 over 1/3, and here you get 1 over 1/3. See, you have the same answer. Okay, so you do not need to factor it here, but if you can, that's great. Okay, so those are the possible inflection points, but we don't know whether they are inflection. We're not sure they are inflection points yet, because we need to show a f prime prime really changed signs. Okay. So what is the domain? Well, the domain is polynomial. For polynomial, the domains are real numbers, right? And then we can draw a diagram. The real number line separated by the important points, which are the critical points. And so where do we put the minus 1 and 1? Okay, because the next important points are the plus or minus 1 over root 3. That is smaller than 1. So we put the 1 here, and then we put 1 over root 3 here. So here we have minus 1 over root 3, and here we have negative 1. Okay, well that separates into many subintervals. So minus infinity to minus 1 to minus 1 over 3, root 3, minus 1 over root 3, and 0, 0, 1 over root 3, 1 over root 3, and 1, 1 to infinity. Okay? And then, so we have f prime, and f. So it's a combined table. Okay, you want to put all the information in one table because then you can figure out the shape. Okay, so let's look at f prime, the first derivative. The first derivative, okay, so those are our critical points. So remember those critical points? How do we find those? We set the derivative 0. So it means at those points, f prime is 0. So here is 0, here is 0, here is 0. Okay, and then on each piece of the interval, we plus some points. Here we can pick -2, okay, and then we plug in the factored form because we're able to see whether each factor is positive or negative, and then we count the total number of negative. Then we can know if it's an odd number of negatives, we get negative. If it's an even number of negatives, we actually get positive. Okay. So we plug in -2, 12, -2 is negative, -2 plus 1 is -1, negative, -2 minus 1, -3, negative. So 3 negative give us negative. Okay, so here actually you can see these 3 pieces, they are separated by the critical points, -1 and 0. So they actually have the same sign. Let me see. I can pick the number maybe minus 0.5. So then minus 0.5 is negative, minus 0.5 plus 1 is positive, minus 0.5 minus 1 is negative. So 2 negative give us positive. Okay, here they will have the same sign as well. Okay, all right, because the only points that change the sign of f prime are the critical points, -1, 0, and 1. So that's why this all 3 pieces, they will have the same sign. We can pick 1/2 to plug in it, like 0.5, right? So 12.5 is positive, 0.5 plus 1, 1.5 positive, 0.5 minus 1, negative 0.5, negative. So we have 1 negative, give us negative. Okay, here we can pick the number 2. So 12x is positive, 2 plus 1 positive, 2 minus 1 positive. All the factors are positive, so we get positive. Okay, so remember, you can always pause the videos and try to work on it first. All right, next, f prime prime. F prime prime, what are the possible important points? Okay, so those are -1 over root 3 and 1 over root 3. So at those points, my second derivative is 0. Okay. And then, so here, these 3 pieces will actually have the same sign because the only points that change the signs, possibly change the sign of the f prime prime are the -1/3, 1 over root 3, and the 1 over root 3. Okay, so we can plug in -1 in it. We can choose to plug in here or here, so it doesn't matter. Okay, maybe we can plug in here. So when we plug in -1 squared is 1, 3 minus 1 is positive, so we have positive here, then it must be positive here as well. Okay, can we find a number? So this 3 pieces will have the same sign, so we can pick a 0. When we plug a 0, we get 3 zeros. So 0 minus 1 is -1. So we have negative here. Then we have negative here as well. Here we can plug in 1. 3 minus 1 positive. So we have positive. Okay. Yeah, so if you can understand like all this will have the same sign, all this have the same sign, all this have the same sign. So you don't need to pick each value from each of the pieces, right? We actually just plug in 3 values and we get the sign. If you don't realize this trick, you're gonna plug 9 values, and that's a lot of work. Okay, so sometimes I can share some tips with you, and then you can complete the problem faster and make it simpler. Okay. Because I saw like some students in the previous semester, I saw like sometimes they have negative here, and then maybe positive here, and that's so they make some mistake. So all of these 3 things should be the same sign. Okay, but if they make some mistake and plug in the wrong number, they might get different sign. Okay. All right, so for F, we want to write, what color? Okay, how about blue? Okay, so for F, we want to draw the shape, the actual shape. Remember the shape is like a circle. You divide it into 4 pieces. Okay, be careful. Don't draw something like a parentheses, okay? Because the parentheses, can you tell me this guy is increasing or decreasing? I can't tell. So here is increasing, here is decreasing. And actually, this guy is not a function because the vertical line passes through 2 points. So when you draw the shape, make sure it's either like that, or like that, or like that, or oops, that's not good. Like that or like that. Okay? So don't draw like a C or like a parentheses. Okay? And don't draw like an S. Okay, so let's look at the first one. We have f prime negative, f double prime positive. So the function is decreasing and concave up. That is what? Decreasing and concave up is the left lower corner. So we have like this. Okay. And on the points, it's just points. So usually you fill in either inflection points, local max, local mean, on the points. Okay, we draw the shape on the intervals. So here we have the intervals. Okay, so because f prime and f double prime are both positive, so we have increasing and concave up. So increasing and concave up is right here. Okay. Here we have increasing and concave down. Where's increasing and concave down? All right, the shape like that. And here we have decreasing and concave down, decreasing and concave down, the shape like this. And here we have decreasing and concave up, so that is like this one. And then last we have increasing and concave up, so we have this one. Okay, so those are the actual shape of the graph. All right, then imagine what happened here. So you have this shape, and then after this point is this shape. What do you tell about this guy? This is a local mean. Okay, and this guy, you can see increasing, and then like, oh, this is neither local max nor local mean, but it's an inflection point. Okay, here we have like this guy, and then this guy. This is a local max. And this guy we have decreasing, so yes, so this guy is inflection point. It's all decreasing all the time, but it changed concavities. Here we have decreasing and increasing, so this is a local min. Okay, everybody? So that is the diagram. Do you remember what is the next step? We plot the important points. What are the important points? -1 over root 3, 0, 1 over root 3, and 1. Okay, what happened when we plug in 1? So our function 3x to the 4th minus 6x squared. Okay, let me put it here, 3x to the 4th minus 6x squared. Okay, the first one. When we plug in -1, it's just like 3 minus 6. it would be -3, right? Yeah, because -1 squared and the 4 and it's just 1. Okay, how about this guy? 1, so negative when we to the even power just become positive, and then 1 over square root of 3 squared is 1/3, and x to the 4th is like 1 over 9. -6, this is 1 over 3, so we get 1/3 minus 2. It would be what? 1/3 minus 6 over 3. That is -5 over 3. When we plug in 0 is 0. Do you realize this guy is actually an even function? Because all the terms are even power. So f of 1 over root 3 is the same as f of -1 over root 3. So this is -5 over 3. And f of 1 is f of -1. So that is -3. Okay. So we have the important points. Next, let's draw our picture. So it's very gonna the important point are very symmetry. So we have the real number line. Okay. And then x, y, 0 important points, 1, -1 over root 3, 1 over, oops, this is positive, this is negative. Here we have -1. Okay, let's plot the points. Okay, at -1 we get -3. Okay, -3 is like here. And -5/3. -5/3 is like around -1 point something. So here. Okay. Remember, you're gonna plot the point and tell me what the value is. Okay, you don't just put the line here and you have to tell me what number it is. Okay, and then at 0 we have 0, and then here we still have the same points. It's symmetric about the y-axis. Okay, let's look at the shape. Okay, so the first shape we have going down, and so we connect these points and then using the shape, so it looks like that. And then when we connect them, don't draw a straight line. Is actually like this guy. Oops, let me draw it better. Okay, and then connect this guy, we have this shape. And connect those two guys, we have this shape. Try it again. Okay, and then connect this guy, we have this shape. Okay, so we should be able to see whether it's concave up or concave down, and eventually like that. Okay, so this is the sketch of the graph. All right. Okay, and that's it for session 4.2. Bye.